when we try to predict the weather, we usually look at historical averages, right? Like we
Yeah.
guess the probability of rain. It's basically just an educated roll of the dice. But imagine if you didn't have to guess at all. Imagine if you could calculate the exact physical path of every single raindrop before the storm even started.
Yeah, and to do that, you'd basically have to dismantle the entire concept of randomness, which honestly is exactly what today's deep dive is all about. We're jumping into a really dense, multidisciplinary framework called the Dillon Architecture.
Right. And our mission today is to, well, unpack this thing for you because the core claim here is that everything from quantum physics to data encryption isn't governed by chance, but by strict, predictable geometry.
Exactly. It claims the universe is caught in this physical tug of war. On one side, you have syntropy, which is, coherence and structural healing. And on the other side, entropy, which is fragmentation and chaos.
And to prove the universe is totally deterministic, the author, Timothy J. Dillon, starts his case in a really unexpected place. Live sports betting. I mean, how do we get from placing a wager to redefining physics?
Well, it all comes down to latency. When you're betting on micro events in real time, like tracking the exact boundary of a baseball pitch, you can't have any probabilistic ambiguity. Money is changing hands in milliseconds based on physical truth.
Oh, wow. Okay, so he had to build a system that defined discrete, absolute boundaries for those physical events.
Yeah, exactly. He built these patents for micro-event wagering. And then he took that intense demand for exact boundaries and pointed it at pure mathematics. Specifically, he took aim at the Collatz conjecture.
Wait, so that's the famous math riddle, right? Where you take any number, have it if it's even, or multiply by 3 and add 1 if it's odd, and see if it loops back down to 1. I mean, people have been stuck on that for almost a century.
Right, and mathematicians usually treat the chaotic rise and fall of those numbers as a random walk. But Dillon introduced this concept called omega calculus.
Omega calculus. Okay, so how does that solve it?
So instead of tracking the raw size of the numbers, this calculus measures their hidden geometric harmonics. It essentially proves that numbers don't bounce around randomly at all.
They're being pulled by something.
Yeah, they're pulled by an underlying geometric drift. It forces them to contract into that 1-4-2-1 loop deterministically.
Okay, so if abstract numbers are bound by strict geometric paths, it brings up a wild question about the physical world, especially regarding the ultimate boundary like the speed of light. The report's claim on physics here completely lost me.
Right, so it introduces curvature variable physics. The standard model treats the speed of light as a constant scalar, but this architecture argues that light speed actually changes based on the curvature of local geometry.
Okay, and if physical space warps this way, digital information logically has to do the same, right? Which leads to the claim that P equals NP.
Yes, exactly. Meaning problems that are supposedly infinitely hard to solve are actually just as easy to solve as verifying the answer. If that holds true, modern cryptography just completely collapses.
So things like SHA-256 encryption, the backbone of all our digital security, just breaks.
Yeah, the report calls our current encryption a geometric illusion. Instead of guessing a password trillions of times, the system projects the encrypted hashes against a universal ROM, which is basically a baseline of mathematical constants like pi.
Let me make sure I'm visualizing this for everyone. It sounds like trying to find the exact right key for a massive vault, but instead of trying every key on a keychain, the lock itself physically rejects wrong keys before you even insert them.
That is a great analogy. The math actually uses the terms smooth and rough. Incorrect passwords hit a structural roughness and get discarded instantly by the geometry without guessing.
Oh, I see. Well, the correct password just slides through mathematically smooth.
Exactly. And because software security is so exposed by this, the architecture proposes building physical geodesic shields into silicon microchips.
Geodesic shields. So we need physical hardware to block these mathematical collapses. That is insane. But, what about human behavior? Does this framework suggest we're just following a geometric script too?
Kind of, yeah. It maps human markets and behavior as deterministic structural pressures. Take finance. Their Omega Genesis structural risk engine doesn't view market crashes as random black swan events.
They're inevitable structural failures. They even have an archetype for it called the pressure cooker, right?
Right. But it goes way past Wall Street. They actually sent 29 omega point theorems to Pope Leo XIV.
The Pope who has a math degree. I mean, translating pure geometry into theology is just wild to me.
It really is. The architecture mathematically models syntropy as grace and dispersion as sin. The equations literally treat compassion as a geometric operator.
So, an act of kindness is mathematically plotted as a force that reduces the adversarial distance between conflicting agents. It's, mapping relational morality onto a graph.
Yes. Every system, whether it's a stock market, a computer network, or a human relationship, is either fragmenting into chaos or mathematically contracting toward order.
Which means that your data, your investments, and the physical reality around you are completely predictable structures. They aren't games of chance.
Exactly. The illusion of randomness is just that, an illusion.
And that brings us right back to calculating the exact path of a raindrop. It's a lot to wrap your head around.
It really is, but it completely changes how you look at the systems we rely on.
Absolutely. So we'll leave you with this one final thought. If syntropy proves mathematically that compassion physically heals structural decay, could we one day program global AI infrastructure to mathematically forgive our digital footprints?
Wow, that is a big question.
Something to mull over until next time.